Hey everyone. In this video, we're going to look at another method to solve systems of equations. In this video, we're going to look at the elimination method. So this elimination method is very similar to the substitution method in that we want to take our two equations, two variables, and we want to combine them together in such a way where we end up with one equation, one variable. And once we do that, we can actually solve for that first variable, and then just like before, we'll use a little back substitution to solve for the other one. So what I'd like to do, take a look at an example, and as we go through it, we'll talk about each of the steps on how to solve this. So here's my system. 3x plus 2y is equal to 24, and my second equation is 9x minus 8y is equal to negative 12. So in elimination, the first step, the first thing I want to do is we want to decide which variable we want to eliminate. Okay, so it doesn't matter which one we choose. We can choose x or y. And just like we saw with substitution, sometimes there's ones that are going to be easier than the other ones. In this case, they look relatively similar, so I'm just going to choose the x's. So by choosing x to eliminate, that means we're going to solve for y first. Now, after I choose x, the next thing I want to do is I need to set up opposite coefficients. So that means when I combine these equations together, since the x's will have opposite coefficients, they'll cancel each other out. They'll be eliminated. So taking a look here, the two coefficients I have on my x's, I have a positive 3 and a positive 9. I want those to be opposites. So I'm going to take this first equation, and I'm going to multiply this entire equation by negative 3. So let's write that down. So we have 3x plus 2y is equal to 24. And I want to multiply this entire thing by negative 3. Multiplying this entire equation by negative 3, what I'm going to end up with is a negative 9x, which is what we wanted. So I have a negative 9x, and then when I combine that together with this second equation, the positive 9x, those will cancel out. But let's continue multiplying. So here we have a negative 6y, and on the right-hand side of the equation, that's going to be a negative 72. And underneath this, I'm just going to rewrite my second equation. So the 9x minus 8y is equal to negative 12. And here, this is where we want to combine these equations together. So I'm just going to treat this as kind of an addition problem, but we're going to take the two equations and we're going to combine all the like terms. So all my x terms will get added, the y terms will get added, and the constants will get added. Notice how everything is nice and lined up here as well. The x's are stacked, the y's are stacked, even the equal signs are right on top of each other. So combining the x's together, we end up with 0. The whole reason why we set up those opposite coefficients is because we wanted that result. We wanted the x's to be eliminated. The two y values, negative 6 and negative 8y, that's going to be a negative 14y. And negative 72 minus 12, we get a negative 84. So we end up with this simple equation of negative 14y is equal to negative 84. So again, we were able to go from two equations, two variables. We combined them together in such a way that we ended up with one equation, one variable. And now we can solve for y by dividing by negative 14. And we end up with y is equal to 6. And now that we know that first one, we can do a little bit back substitution to find our second variable. So I'm going to go back up to one of my two original equations, and it doesn't matter which one I pick out. I'm just going to use that top one. So 3x, and then now 2, and we'll substitute in the 6 that we found for y, and this is equal to 24. So 3x plus 12 is equal to 24. Subtracting 12 from both sides, we get 3x is equal to 12. And to finish up, dividing by 3, x is equal to 4. And there's our two variables. And just like before, the two equations in my system, these do represent lines. And the solution to this system is their point of intersection. So to write my final answer, we'll write this as an ordered pair, 4, 6. And there's our solution. So the last thing I want to do is I just want to compare this back to our substitution method, just because it is directly related. So the first thing we did is take this first equation and we multiplied it by -3 to set up those opposites. Over here, I'm just going to multiply it by a +3 instead. And that gives me 9x plus 6y is equal to 72. Now, written like this, I'm going to subtract 6y from both sides. And I end up with 9y is equal to -6y plus 72. So I end up with this expression of -6y plus 72. That whole thing represents 9 times x. In my second equation, I have a 9 times x. So with substitution, I can replace 9x with this expression. And I end up with -6y plus 72 minus 8y is equal to -12. And here, again, we have one equation, one variable. And if I start combining my like terms together, hopefully you can see that we end up exactly what we ended up with doing our elimination. Right? We substituted out the 9x, which is the elimination piece. We were able to get rid of that. We have a -6y and a -8y, which gives me the -14y here. And then lastly, if I subtract that 72, we end up with the -84 that we saw earlier as well. So the two methods are directly related to each other, but when we do elimination, stacking it up like this, it does make it a little bit of an easier process.